Greetings, Bill Gerald here, Chief Energy Engineer for CalPortland. Today I am at the Red Mountain Ready Mix Plant. It's in Mesa, Arizona. It's on the east side of Phoenix. Came here today to have a treasure hunt opportunity and visit the plant, talk to the personnel, management about the plant, how it's operating, kind of crawl around it and see how it's performing. Red Mountain is a plant that just recently constructed. The plant was brought from another location here in the Phoenix Valley area and put together. Jake Nieman is the plant manager, and he was instrumental in putting this plant together. And I expected there to be pretty good results here and a lot of good positive energy uses here. And we're going to find out today. We're going to visit. We're going to talk to him, and we're going to see what's going on. So here I am, Red Mountain. We are in the middle of the COVID-19 pandemic, so we are making sure that we properly follow all social distancing rules, including masking up as required. I'll be pulling my mask off at times when there's no personnel around, but I want to make sure everybody's aware that we are following the social distancing guidelines and appropriately making sure that we are following all rules. Now you see me. So we were talking to the plant manager, Jake Nieman. Excuse me. We were talking to the plant manager, Jake Nieman, and discussing all the plant loads, trying to find out, making sure we understand the sources of energy consumption. Most ready mix plants are pretty typical of each other, but want to make sure you discuss all of them. What we have here is the transport blower. So it's going to be either moving cement or fly ash powder. Right next to it is a big guppy storage tank where it's loaded with fly ash. And that blower, I'm told, is primarily used to move the fly ash to the fly ash silo right here behind it. That's its primary duty. Not of run time. Most trucks coming in that are blowing off cement in this property, and most of Phoenix for us, the trucks that are bringing in the cement are PTO blower supplied, so the trucks blow off into the silos. But we do have a couple trucks that don't have their own PTO, and so they have to use the electric blower here. So minimal energy consumption from this motor, but still documenting it, make sure we understand what's going on. One of the main areas that we look at, as always, is the compressor. We're going to walk over to the compressor right now. What we have here is an Ingersoll Rand compressor. It's a screw compressor. Plant pressure is approximately 100 pounds per square inch. For us, that's a decent pressure. If the plant's running more than 100 pounds per square inch, should look into why we're running that high. If the pressure is needed, maybe there's some piece of equipment that needs to be looked at, cylinders changed, or some other operation. 100 psi should run a plant fairly well, and I'm really glad to see this plant running in that direction. So ready mix plants, some of them are supplied maybe commonly in the past with reciprocating compressors with a simple on-off cycling. Pressure drops to a set point, bring it back up. This is a screw compressor that's pretty much in a constant run mode, loading and unloading to maintain pressure. I've taken note of the model number. Gonna research and see what kind of settings this compressor has. See if there's any opportunity to adjust that operation. Have a slight concern about, is this compressor how often is it unloaded? Like, you know, right now for the past couple hours, we haven't had any trucks. It's the end of the day for this plant, and the compressor is still running to maintain pressure in the plant to be ready for a batch. But maybe there's some efficiency savings just in runtime and how this compressor operates. So, like I said, I took the manual, the nameplate data, and we'll look up the manual and see what the control panel. Maybe there's some opportunities in there for it to give us some energy savings. You know, another big consumer for ready mix plants is their process water. How do we either heat or cool the water? In this case, we have propane tanks for the fuel supply for the winter heating. Obviously, it's Arizona. It doesn't get that cold, but maybe just chilly enough that we do have to heat some water. And now in the summertime, a little bit more significant for us is chilled water. So all of our ready mix plants in Arizona, Nevada, Southern California, at minimum, those southern region plants have chillers and significant energy user. We've just installed this chiller. It's actually a good time to be doing this treasure hunt. And this is a new chiller to us as a manufacturer. A lot of claims for better reliability, better operation, and energy efficiency. So we'll be keeping a really good close eye on the energy consumption of this plant. It was just installed, and as we go down the road, we'll watch that energy and see if we get any reductions out of this new installation for this chiller. Behind them is the tanks for holding it. Notice they're insulated tanks for holding that processed water. Very important to have insulated tanks. Pretty much a common practice, but want to make sure we note it so that we know what best practices are. This plant, as all plants, you need an aggregate supply. You need to get your sand and rock into the ready mix plant. We got five belt conveyors here from the hoppers feeding into it. You have a 1/2 inch, 5/8 sand. You have a 57 belt for the 1 inch rock, and then you have a specialties belt. There's just one belt that's kind of coming off at an angle with this hopper right behind me. Specialties going that. Now, this plant's moved many times actually in its CalPortland era, and probably even before it was CalPortland plant. And it was moved from a previous location that was in Phoenix. And what Jake told me to make sure noted is these belts used to be on a manual control outside of the batch operator's room. So when the plant was not operating, when it was not batching, these belts would continue to run because, come on, and we're human beings, and you may not walk out there to actually flip the belt off every time that you need to turn it off. Well, when they rebuilt this plant, Jake smartly had these conveyors connected to the Janelle batch panel system, and so they only run as required. It's an automated system. That's big energy savings there, right? May sound like a no-brainer, but there's plenty of plants out there that are still running in a more of a manual mode. Maybe feel like they don't have time or the money to make that conversion. But you can have some significant savings by keeping these belts not running. These belts are 15 horsepower motors, 5 belts. That can add up into quite a bit of money from the energy. Looking at the energy data for this plant, this is the utility for this plant is Salt River Project, SRP. Our local rate for this property, it's a commercial rate, is between 12 and 15 cents a kilowatt hour, depending on the time of the year. Some of our rates are higher. That's a fairly moderate rate. We have obviously significantly higher rates in California, but for Arizona, 12 to 15 cents for this size operation is pretty standard and what we expect to see. So the compressed air system, I walked around the plant earlier, really wait for that noisy compressor. So I'm really impressed by the tightness of the compressed air system. Pretty good, not a lot of leak noises. And what they do have that's really of value here is they have a lot of receiver tanks, right? It's really built with thought. Right here is one of the first ones. 200-gallon receiver. The more volume you have in your plant, the better that the compressor is going to have less stress on it. So that 200-gallon receiver is part of the system. Above me where the charge belt is, here you got the charge belt going uphill, and there's another receiver up there for the solenoid valves. You know, obviously for a ready mix plant, solenoid valves and cylinders are, you know, a big part of the operation. You need these to actuate when you need them. You need to operate, you know, fast and sharply. That's why compressed air is important. We had a long conversation with management and the operators of the plant, explaining to them the significance of compressed air. Remember, it's like a 7-to-1 ratio, 7 horsepower of electrical energy just to create 1 horsepower of compressed air. That's a fairly inefficient conversion, but compressed air is such a simple system, and it's a great utility that, yeah, of course, us in industry, we're going to use it. We just want to make sure operators are aware of this is why leaks or impractical uses of compressed air is important to monitor, because it's expensive to create. 15 cents a kilowatt hour times that motor rating. This compressor will use a significant portion of the energy and power at this plant. This plant has dust collectors and bag houses. Bag houses on top of the storage bins. Every once in a while you might hear cycling. Maybe I'll point it out there, right there. You heard that was the fly ash silo. There's another one banging right there. So these are the diaphragm valves pulsing compressed air, blowing out the bags, keeping them clean. So the silo bag houses are going to be constantly running. Now there's also a dust collector and fan for the loadout, and this has a bag house as well and a blower that would be running. Significant here, and what should be at all plants, is when the dust collector, you only need it to run when you're loading a truck. Let me show you here the loadout. Here's the loadout right there. The truck's going to put his spout underneath that. Yeah, that's the neighbors blowing something up. And then here's the bag house right there, the dust collector. And that fan's not running right now. The fan doesn't need to run unless the charge belt is feeding a truck, right? That's good. It's great that we have these interlocks. So keep that fan not running. Only run the fan when the truck is being loaded. That's great. We had a previous, a lot of effort going in and retrofitting some older plants. These draft fans would run all day long, right? The operator come in, turn that fan on, and there's only one way to turn it on. It had a start stop button out in the field, and it would just stay on. Now, interlocking these fans with the charge belt, so it only runs, it cut down dozens of hours down to maybe an hour, because you know you only need it for 5 minutes to load the truck, so why run it that entire time? So it was a great project, and for here they've already got it set up. So this is a great plant. It's well maintained. It was set up right. It's got a tight compressed air system. It's got LED outside lighting. It's really nice. I'm very proud of this plant. I'm excited to write the report on it and talk about all the positive attributes of this plant as far as the treasure hunt goes. I didn't expect to find any major issues, but it was good. It's good as positive. Note the positive aspects and share them with our other operators, so that we can make sure we're doing some of the same things. At this location, I installed a data logger, so that I'm going to monitor the compressor and watch its pressure, just see how it's operating over a few weeks. Come back and pick up that data logger and download the data and just see what the results look like. I'm curious to see what the air pressure does when the compressor is stopped every night. Right here is another receiver, and that's where I put it. I put that data logger at the receiver, and it's a Hobo data logger. It's a newer one, so it's got a Bluetooth connection, and I was able to configure it right from my cell phone. Previously, I'd have to have a laptop and a cord and set it all up. Now, Bluetooth connection, cell phone app, really simple. I'm really happy about how easy it was to set that up. Obviously, part of the energy of this property would be the batch office, the driver's lunchroom. Minimal load, but consideration. Looked pretty good. We have at this operation a truck shop going up for working on trucks. You know, this is a unique situation for ready mix plants as far as when we're benchmarking against each other. Not all plants have truck shops, and you know, now we've got this energy consumption that's added to this particular plant. Currently, this shop is not operational. I don't even think it has any power to it yet, but maybe down in the future we'll have to keep an eye on it and even consider do we sub-meter out that power. You know, it's not critical, but if we wanted to have exact numbers, it you know, something to consider for you know, the operation. Every batch plant has admixtures and colors. We take a, you know, kind of a casual look at this. Not a lot of energy consumption in these devices. I do get concerned sometimes with plants that are in the north because they need to heat these a little bit more and keep the systems warm and not, you know, don't let them freeze. So that heat load can be something that's it can end up being significant. Doesn't appear to be much here. The diaphragm pump is not moving much to make a huge energy concern. Kind of another look at this batch plant. Really well maintained, clean. The operators were doing a great job. Lisa, the batch operator here, she was obviously conscientious and you know, doing her job. And we had a long discussion talking about energy impacts, talking about the compressed air. You know, the great opportunity here at this plant is that, as I've said, it's a very tight, looks like a minimal leak compressed air system. So I'm hoping that she's got her ear tuned up that when she does hear a leak, we can jump right on it and repair it, and not just let it slide, because right now we've got a good thing, and let's keep a good thing going. The outdoor lighting, one of the first things I do when I drive on a treasure hunt, I drive up to the plant, is the outdoor lighting off. And sometimes you got photocell problems, timer problems, whatever else might be the excuse. This plant, no outdoor lighting was on, right? They knew I was coming, but I don't think that's why it was off. I think it's a good plant. LED lighting, we're doing a lot more LED lighting. Really happy to see that. It's such a good quality light. Great to work by. And they got all their outdoor lighting is LED. Here I'm kind of standing underneath one right here. Nice pretty LED light, energy efficiency, and overall, I think one last send off from Red Mountain. It's a great plant, and I'm gonna be happy to write this report up and send it out. Talk about the great things happening here, Red Mountain in Mesa, Arizona. Thank you. It's Bill Gerald, Chief Energy Engineer, and hope you have a great day.